It's really great to be here today. I brought some shopping with me. I have some sweet dessert for later. Maybe this afternoon, later on when we're feeling a little bit tired, I've got some green tea to perk me up. And I have some sugar for my green tea. I've got a sweet tooth. And I have some cider vinegar, which will become a little bit clearer. So, okay, this is the contents of my shopping bag today. This is the one ingredient that's missing. This is the magic ingredient, I guess. And it's the one thing that ties these things together. This ingredient, so this is my health drink and the sweet dessert. But in addition to those, all these other things have been made possible by that magic ingredient. So up here we've got blood vessels which can be implanted into the human body. These Sony headphones contain an acoustic membrane made from this material. And this nutrition-giving face mask is the same thing. And then finally a garment. What all these things have in common, and all these products here, and my shopping bag, is that magic ingredient. So what's in the special sachet? These guys. So these really attractive creatures are Acetobacter. They're bacteria. So that little silver pouch that unfortunately I couldn't bring with me today is a sachet of life. It's living organisms. More specifically, it's something that you might be familiar with in this form. So this is a home brew of kombucha. It's called different things around the world, so I guess it depends where you come from. But this is your green tea, your sugar, some sort of acetic acid, so in this case cider vinegar, and then our sachet of life, our magic ingredient. And that is a mother culture, which is what you can see floating on the surface. So this recipe has been out in the world for thousands of years, literally, and countries all around the world, people are brewing this at home. It's releasing all kinds of enzymes that are believed to have a health-giving effect. So what I'm interested in is actually that the byproduct of this fermenting liquid is a material, and the material is cellulose. So what you can see in the film here, that dark shadow is called a mother culture. And it's also called a SCOBY, which is a symbiotic culture of yeasts and bacteria. And essentially, you put that into your sugary green tea mix, and that living organism of yeast and bacteria feed on the glucose in the liquid. So as they synthesize the sugars, they're spinning nanofibrils of cellulose. And cellulose is something that we kind of associate, it's the most abundant biological material on the planet, but we think of it as being plant-based. But actually, microorganisms can also produce cellulose, and it's a very pure form. So what you're seeing here, the bacteria are swimming around in that nutrient solution. They're feeding on the sugar, and they're converting it into an acid. But at the same time, they're producing these threads. And the threads are coming together, and they're forming into layers. And the layers, after a period of time, form at the surface into a mat. There's a lot of oxygen being produced, and you can see that being trapped under the bubble there. This is obviously a time lapse reducing about 10 days growth into just over a minute, I think. And afterwards, that's what it kind of looks like, so it's really attractive. But that layer at the top is pretty much pure cellulose, and it's about 98% water as well. So what happens is, so I've kind of rethought this whole process, okay? So lots of people are brewing this at home and using it to create this drink. So this is the commercial version, a kombucha-style health drink. And that fermentation process is being used to create that product. It's also being used to create this sweet dessert. So this is very big in Indonesia. It's called nata de coco. And this is actually that material on the surface. But I became really interested in the material as a material in its own right. So something which is organically grown from this biological process. So what you see here are two growth baths. This is in my studio. We have a big vat of sugary green tea, and it's sitting on a heat mat. And that's being controlled by a thermostat because the best conditions for it to grow are about 25 degrees centigrade. So you can see the sensor going in there. That dark patch in the corner is the SCOBY, the mother culture. So that's the living organism that's placed into the vat. And 2 weeks later, we have a sheet of material. I have a sort of scaled-up version when I'm making something. This is my mini material farm. So very low tech, and in the summer, actually, I don't worry about the temperature. I just leave it outside, and the heat, hopefully, if we have a nice summer, will allow it to grow by itself. And then when it's ready to harvest, it's taken out of the bath. It looks delicious, doesn't it? Washed out in cold soapy water, and then laid out to dry. And again, just air drying. We just need to let the water evaporate from the material. So in 2 weeks, you're growing something which is about 2 centimeters in thickness. But actually, that's 98% water. So once the water's evaporated, what you're left with is like something about 1 millimeter in thickness. So it looks just like this. If you want to come up to me afterwards, you can. This has come straight out of the bath as dried. It's not been washed. So you can actually smell the process which has made it. You can sense that if you feel like it. But actually that material can then be used in different ways. So just from the basic process, without doing any particular modification, you can actually use the dried material, cut it out and sew it quite conventionally, or mold it around a three-dimensional form. And you can see here, it actually, when it's wet, molds extremely well around a wooden form. So this is just lots of experimenting, playing around with the material. So on wood, it adheres very well because it's cellulose onto cellulose. And I was interested to see actually if we can also think about joining the material in ways which doesn't require a conventional seam, for example. So these were just sheets of cellulose bleached out and overlapped. And actually what happens is when the water evaporates, the fibers actually knit together in a really strong bond. So normally on a garment where you have a stitched seam, that's actually a point of weakness. But with this, the 2 layers of cellulose coming together become a point of strength, so it's even stronger on the seam. So that was kind of interesting. And then as it's drying, it's becoming transparent, and patterning can be cut into it just to create a simple shape. So this was the very first kind of prototype of a garment which has just been grown using a living organism coming out of a vat of liquid without any stitching, but forming a three-dimensional garment. I then went on to kind of make a series of garments exploring the material and the fact that it has a sort of leather-like quality. Although my background is fashion, for this whole project, because it's taken a much longer period of time, I wasn't really interested in making anything to do with trend. So what I decided to do for prototypes was produce kind of iconic pieces. So garments that people would have in their wardrobe all around the world from, across decades. So timeless, iconic pieces. So this was based on a classic Levi's denim jacket. It's been completely hand sewn, actually. And then it was garment dyed. So it was dyed in indigo. And we compared it to cotton in the way that in order to create a very dark denim, you might need up to 18 dips to achieve a very dark color. But because the cellulose loves water, it's hydrophilic, it not only takes up water quickly, but it takes up the color very quickly too. So this only took 1 dip to get to the same dark stage as a conventional denim, which obviously saves a lot on the chemicals in the dye. And then that's the final version of it. So these garments that I'm showing you, I'm not wearing it today because this one's biodegraded. And they are all very much prototypes. They're not in the shops, and they're not likely to be in the shops anytime soon. But I guess for me, they were provocations. It was really a case of saying, is it possible to make these things? And actually, put it out there as an idea and then come back to figuring out all the material quality issues that I've discovered along the way. which is a much bigger science project. And then inevitably, when you're experimenting, you make discoveries. So just drying things on a wooden sheet, one of the sheets happened to have a metal nail in it. And when I came to see it dried, it had turned black. And I realized, well, we have a way of introducing color without using any printing or pigment dyes or any extra chemicals. So the chemical processes themselves can actually lend towards producing something which is more of an eco-patination. So that's what was used here. Then we started thinking about how you might actually engineer that into a mold. This was a kind of response to that in a way. It was thinking about garments that have a lot of metal in, and a black leather biker jacket, which is full of metal studding, seemed to be quite a fun thing to play with. So what we produced was a veggie biker jacket, where instead of the metal being put on afterwards, we put the metal onto the sheets and allowed it to oxidize to produce a kind of negative of a biker jacket. So this is the compostable version of your biker jacket. The only thing, unfortunately, that no one has yet designed is a zip which you can compost. So you'd have to cut that out. But other than that, the garment could be thrown out with your vegetable peelings. And so this is what you're seeing here today. It's traveled quite a lot. It's been in lots of exhibitions, so it's actually, again, biodegrading now. And it's subject to changes in humidity. So as it sits here, it will probably start to kind of sag and collapse on the table. But this is using that system. So basically designing a mold, bringing the metal patination into it, and then overlapping the edges of the material so that it forms the seams. And then just waiting, really, for it to dry and produce a kind of patterned effect around it. So this is my shopping bag that is made from all the ingredients in the shopping bag. So just to kind of go back to the beginning, you might be wondering how on earth I kind of came to be doing this. As a fashion designer, I guess I'm a bit of a science fiction fan. I'm always really interested in what the future is. I was researching a book on the future of fashion and technology. But I was asking, not what are we going to be wearing next season, or even next year, which are the more frequent questions you're kind of thinking about in fashion, but much more future than that. So saying, what might we wear in 50 years' time? And how do I begin to understand what that might look like? I figured that I wasn't going to find the answer by talking to a bunch of other fashion designers. So I decided that what I needed to do was to talk to people who were working on materials or processes that maybe weren't yet out in the world. So what was going on in the laboratory? And one of the people I spoke to was a material scientist with a biology background. And he said to me, well, we don't need to be making things the way we always have. We could grow a dress in the laboratory. So that was, thanks to him, the starting of the project, because it was a complete revelation to me. And I just thought, wow, what on earth, what does that mean? What does that look like? How would you do it? And so very informally, we started a collaboration, which was just in his garage, in my bathroom, playing around with ingredients and testing things, and then it sort of bloomed into a much bigger project. I think, too, at that point, it was just a kind of fun conceptual question. There wasn't any particular driving inspiration behind it. But then, as years have gone by, I guess what I realized is that there are a whole bunch of questions going on in the fashion textile world to do with sustainability, how we make things, where our resources are coming from, end of life, and so forth. So these were the systems that, this is what we currently deal with. Petrochemicals that are giving us polymers, to something which is really not just going towards landfill, or, a more conventional piece of accessory where you've got an animal, it takes up land, it needs feed, it needs antibiotics, and that's even before we've got to the point where we remove its skin, we treat it with toxic chemicals, and we end up with a product like this, which is still disposable, but is going to leach all those things back into the soil. So it seemed like, okay, there is a reason maybe for really taking this forward and thinking about this system instead. So, okay, we need nutrient and we need the sugar in the tea and the vinegar, but there are different ways of thinking about that. So those same nutrients could come from a different source. So while I might start a new culture today, and you could go home and try this yourself using these ingredients, you could also go to industry, the food industry or a soft drink manufacturer, and take a waste stream from one of their factories. So for example, I found one online in New York City that was offering thousands of gallons every week of sugared water. Well, that's the perfect nutrient source for this. So into that sugared water, I would only need to add a few microbes, and I could start a culture to grow all these materials. At the moment, you can find the materials in different forms. So at the beginning, I showed you a picture of blood vessels and this stuff here, the sweet dessert. And they're grown in very different ways in different parts of the world. So on this side, we've got a very expensive bioreactor, which is producing pure bacterial cellulose, but for wound healing. So this is completely biocompatible, and you would put it on your skin to heal a wound. Hugely expensive, millions of pounds investment, patented, and so forth. And then at the other extreme, we have people who are growing a material in small villages in Indonesia with next to no money, using coconut water as the nutrient source to produce a foodstuff. And I bought this in a supermarket in Chinatown in London for just £1. So they're the current two extremes. There is no existing production facility for this way of thinking. So we've got these two radically different extremes. And I think it sort of sits between the fermenting brewing industry, the food stuff, and the biomedical. And I think my vision for the future is where product or consumer goods might form another image of that. What might that look like? Oh, let's just go back for a minute. Because the other thing is that this bacteria is your factory. So the bacteria itself is given a nutrient, spinning you a thread, then forming that thread into the material, and ultimately could be shaping that material into your desired product. That's slightly more complex, obviously, than growing it in a sheet form, but it's completely doable. So you could put your shoe last into a vat of liquid and have the bacteria attracted to it. So your factory is producing everything. It's producing the fiber, it's shaping the fiber into the material, and the material into the product, potentially in one system. So think of the sort of savings on resources that might offer. The next stage, the next kind of big future jump, is thinking about, well, okay, if the bacteria is our factory and it's producing this stuff for us, what if we optimize the factory itself? And here we get into the realms of synthetic biology, where we start to engineer the organism to be the optimal, creative production system for us. So you might have come across something called green fluorescent protein, or GFP. When you look at science images, it's often used, it's implanted into a cell to enable scientists to view a living organism more clearly, or what's happening within a living system. But it always used to be this fluorescent green. Since then, that protein's been altered so that you can have a whole spectrum of protein colors. So these colors here at the top, you're viewing in normal white light, and then at the bottom, the same colors under UV light. So there's a potential there to think about, well, if I want my, whatever the product is at the end of it, to be a particular color, what if I could just implant that protein into that bacteria and it would produce the finished thing in that colorway for me? And that's just color. You can think about all the other attributes that you might want your material to have, and how you might then engineer that into the organism itself. So, okay, that's our bacteria. And I showed you some garments and a shopping bag. But I guess what I've really discovered through doing the project is that it's not about fashion, textile accessories. It's just about thinking about materials and production of product. And so this is our factory of the future, which means that we could make anything we like from it. So that could be a lamp, it could be a chair, it could be a car, maybe even architecture. And all these different industries, I think, are looking towards living systems and living organisms as a way of thinking about producing something which is sustainable, which massively reduces the resources we need, and when we want to throw it away, is actually adding nutrient back into the soil and not causing harm. So I guess what I think design can do, perhaps, is to look to things like biology and something which is invisible, the microorganism, to really inspire us about how we might rethink how we design and make things in the future. So I'll leave you with my details.
Thank you. I'm sure the audience has a lot of questions, and so do we. And it looks so simple.
Right. I was just going to grab that.
Oh yeah? Okay. Sorry, I was going to steal it. It looks so simple, and it started from in a sense just a moment of discovery that you were going through, and that started really with a moment of curiosity on your side. But from what I understand and from what I see, it has gotten to be a much bigger endeavor.
Yeah.
And there may be much more road ahead of you in order to actually get to a place where this can be a product.
I mean, absolutely, that's for sure. These are super experimental. There's so much that's wrong with it in terms of material quality. So you can get so far with producing something that looks convincing, but in terms of wear and tear and being stable under different environmental conditions, that's actually a really complex science set of problems, not just one problem, it's a whole set.
But you're saying that there are many people who are interested in solving this problem, both on the industry side, but I'm sure there are people who are interested in investing in this problem. Is this part of where you are right now? Are you collaborating with investors, with people who are head of industry, who are rethinking about their supply chain and the future of it?
Well, very interesting, yes. I mean, there are a lot of brands already who get the whole idea behind this and who are desperate to have the material. Those industries aren't normally used to investing in very fundamental science, R&D. So although it looks like it could be quite close to market, I actually think it's going to take quite a few more years to solve a lot of those issues. I'm up here talking about this. I'm sure, it would be foolish not to believe that there are massive chemical companies like BASF or whoever around the world who are working on the exact same thing, but they're just doing it quietly. And they'll probably be the ones that patent it. I've come at it as a designer, not a scientist.
But of course, the implications are quite large. I mean, you don't talk about it, but one of the things that I learned is how much water is used to just produce one piece of garment.
Yeah.
And so water is a big issue. And in this case, you're talking about using cultures and water being something that is added, but it is not consumed at the same levels. Is that correct?
I've tried to, it wouldn't be fair to compare this to cotton, and cotton is one of the biggest consumers of water, and the figures that you're given for how much water a cotton t-shirt uses are very conflicting. So it can be up to 4,000 litres of water. 15 litres of this liquid would produce the same amount of material. And then once you've got your brew, you can actually use a percentage of that to start the next batch. Right. Same with the culture. So you can literally cut a piece of that surface mat off, and that's still a living organism until you kill the bacteria. So then that can go into the next one and start it. So you don't, it cuts down. Not each time, you still need to add a nutrient, but it is very, very low on what it might use. And I'm sure that, and I'm not even trying to optimize it.
Right.
yet.
One thing that is of course a great transformation, because of course there is a lot in the fashion industry, a lot of talk about water, but also a lot about recycling and consumption and really looking at the cycle. The last thing I wanted to ask you is, of course, this is an incredibly counter culture in a sense of what is happening with fashion, because fashion is really trying to optimize and create a way of production that is much quicker. You know, you go to the store, you buy a t-shirt, 20 people like that t-shirt, somewhere the computer is saying make 20 more of those, right? And here time is actually a big ingredient of the entire process, not only your process right now of discovery, but also the process of creation, right?
Yeah, I mean, I can go into a shop and buy a yard of fabric and make a t-shirt in 10 minutes, whereas this is going to take at least a couple of weeks to do that. But then you also need to get your head around the whole process, because somebody had to go into a field and plant the plant to make the cotton fiber and so on. So if you look at condensing that into one process, actually 2 weeks is not long.
Fantastic.
I had the idea, if you do something like this, you need a lot of trust that something will come out, that you're on the right track, because you're pretty alone in this business. Do you sometimes wake up at night thinking, my fuck, what am I doing?
Every day.
Then I have some great sleeping pills. No, but really every day?
Pretty much, because, you know, it's quite isolating, because I've moved from, I mean, fashion is not hugely experimental in terms of thinking. So, I mean, just operating within a fashion school, you're not going to be having vats of stuff fermenting for your next collection next to someone who's working in something precious.
Yeah.
So.
And what keeps you going?
Because I really strongly believe in it, and I came out of fashion into sort of research because I was just tired of the treadmill of the same product over and over again, and I was just feeling more and more sick about fast fashion, and just when I came across this, I just thought there's so many answers potentially here that I believe in it.
Yeah. Fantastic. Yeah.
Thank you. It's fascinating.